Hi there. This video is about the importance of having balanced ventricular output. What that means is that if the left ventricle pumps out 70 mils of blood with each stroke, then the right ventricle has to do the same thing. If that balance is disturbed, then we have a problem. So let's take a look at what it's supposed to look like. All right, so we have our circuit here with the left ventricle pumping blood into the systemic circuit, being delivered to the body where it exchanges oxygen for carbon dioxide. That returns to the right side of the heart. The right ventricle pumps that blood into the pulmonary circuit, goes to the lungs, picks up oxygen, drops off CO2, and then returns to the left side of the heart. If the left ventricle pumps 70 mils of blood into the systemic circuit, then the right side of the heart has to take 70 mils in. And if it doesn't, then we have a traffic jam here in the systemic circuit. The right ventricle also, at the same time, has to pump out 70 mils of blood in order for 70 mils of blood to go into the left side of the heart. If it pumps more blood in than what the left side of the heart can take and also pump out, then we're going to have a traffic jam in the lungs. So, what can happen to make this balance fail? There are a number of things, but let's just take as an example a myocardial infarction, an MI, in the left ventricle. So we've had a heart attack here. It has damaged some of the tissue of the left ventricle, which means that the left ventricle cannot pump out as much blood as it used to. So where the right ventricle is still pumping out 70 mils, the left ventricle, let's say, has gone down to 60 mils. So there's an imbalance. The right ventricle is putting more blood in the pulmonary circuit than the left ventricle is putting in the systemic circuit. So less blood is coming into the systemic circuit and more blood is being pumped into the pulmonary circuit because the right ventricle is still fine. What that means is that the pressure starts to increase in the pulmonary circuit. The right ventricle starts to get bigger and more muscular because it's trying to push more blood into the pulmonary circuit. And also because it can't get all that blood out, it starts to fill, like swell, with the blood that is remaining behind. And remember, ventricles are not designed to store blood. So all of this is happening, and because of the high pressure, it's actually pushing fluid out of the vessels into the lungs. This is called pulmonary edema, and the fluid actually is in the alveoli and is interfering with gas exchange. It's incredibly dangerous. Okay, so now, because the right ventricle has gotten so big from all the blood that it's not able to push, its function is actually has gotten lower than the left ventricle. So where it was pumping 70 mils each time, it just can't do it anymore. It went down to 60. It went down lower. It's only pumping out 50 mils now. Whereas our left ventricle, our damaged left ventricle, is still pumping 60 mils. So now the volume of blood in the pulmonary circuit becomes lower than the volume of blood in the systemic circuit. This means that the left ventricle is now putting more blood in the systemic circuit than the right ventricle is putting in the pulmonary circuit, and it's creating this higher pressure. Because of the higher pressure, it's going to cause the left ventricle to swell and enlarge in an effort to be able to maintain that, and it's also going to cause edema. This is systemic edema. It tends to show up in the extremities, especially the lower legs and feet, but you'll see swelling in all of the extremities. So it's shifted. The problem has shifted. The left ventricle continues to try to compensate, and this goes back and forth. The left ventricle trying to compensate eventually causes its own failure, which means that it's now performing less well than the right ventricle, and we're back to where we started. This is another diagram showing the same thing. So when the right ventricular output is greater than the left ventricular output, that means more is getting put into the pulmonary circuit, and we end up with high pressure and edema in the lungs. And when the left ventricular output is greater than the right, then the pressure is higher here, and we end up with systemic edema. In either case, what we've developed is called congestive heart failure. So, this is the shape that your heart should normally have. And in congestive heart failure, because these ventricles can't get the blood into their circuit and it's backing up, it's causing this stretch. And at some point, that stretch becomes so great that even when the ventricle tries to contract, it cannot eject sufficient blood and the heart fails. There is no getting out of congestive heart failure. It is a positive feedback cycle that continues until the heart fails completely, but there are treatments that help to slow its progression. All right.